7a, we're going to look at how to do the confidence interval for a mean when we have a large sample. And for the purposes of this class, a large sample is defined as anything 30 or higher. Okay, so remember what we did last class with our Hurricane Katrina situation. So we had an estimate of the number of people in each section. And we knew that wasn't the exact number of people, but we could find a range of numbers. We could take a little off and add a little to our estimated average to find a number that might make sense. And that range is called a confidence interval. All right, so a definition is it's a range of numbers. We are blank percent confident contains the true population mean. All right, and that blank percent is usually given to you in the problem. A lot of times we use 90, 95, or 99%. Okay, and the way that you get your numbers are we take what's called a point estimate or a sample mean. So we have a sample, in our case, like we sampled 10 sections, and we find the mean of those sections. And then we add and subtract some margin of error. All right, now that margin of error, there's a formula that you can find it. All right, but because we live in 2023, we're going to let the graphing calculator do it for us. So here are our steps for constructing a confidence interval. So in your calculator, you're going to follow these steps. Okay, I don't need to read them to you. But once you do that, your screen should look like this. And then this is the things that you need to enter. So you need to enter where it says C level, you're going to enter the confidence level that's given to you in the problem. Where it has the sigma, that's the little O with the tail, that's our standard deviation. X with the bar over it is the sample mean, and then N is the sample size. So let's look at an example. All right, so we have a random sample of 34 home theater systems. They have a mean price of $452.80 and a standard deviation of 88.50. So we're going to construct a 90% confidence interval for that population mean. So we know that these are the things that we're going to have to enter into that screen on the calculator. All right, so our confidence level, 90%. So we're going to put 0.9 as our C level. This is the standard deviation, which they told us was 88.50. X bar is the sample mean, that's 452.80. And then N is the sample size, which is the 34 home theater systems that they looked at. Okay, so now we're going to get our calculator. And we got to go to menu and stat. So you can either go over and press enter, or you can just press 2. And that will take you to the stats menu. Okay, then from here we want F4. This INTR stands for interval, which is what we're finding, a confidence interval. We are doing Z intervals and one sample. Okay, and then I need to press F2. Yours might already say it, so that my data is variable. Okay, and so now we're going to enter these things. So our confidence level is 0.9. Our standard deviation is 88.50. Our sample mean is 452.80. And then our sample size is 34, and then I'm going to hit enter one more time. Okay, and it gives me some numbers, left, right, and then X bar and N, which we already know. Okay, when we write confidence intervals, we write them as numbers in parentheses. So because this is dealing with money, I'm going to round these things to 2 decimal places. So it's going to be 427.84. So 427.84, comma, and then the maximum one was 477.76. All right, so 477.76, and I put this in parentheses. That's typically how we write confidence intervals. Okay, so when you're asked to construct a confidence interval, you're going to get that lower number, that higher number, put them in parentheses. Okay, great. We push buttons on a calculator. Important part, can you tell me what that means? Okay, so we're going to interpret confidence intervals. Okay, here's a sentence that's going to help you. So we are blank percent confident. So for this problem, we did a 90% confidence interval. So we are 90% confident that the true population mean, all right, or in this case, the true mean cost of a home theater system lies between, and that's what those two numbers mean. So I am 90% confident that the actual mean is somewhere between 427.84 and 477.76. Okay, remember this 452.80 came from a sample of 34 home theater systems. Okay, if I want the population mean, that means the average cost of every single home theater system that exists in the world. Okay, that data is way too difficult to find. So I took a sample. My sample mean is 452. So I am 90% confident that the actual mean, if I could actually find all of that data, it's somewhere between these two numbers, somewhere between 427 and 477. Okay, so now a question for you. The study in the previous problem is a few years old, so you think, you know what, the price of home theater systems have to have gone up. All right, so you go to Best Buy and get your own little sample. All right, and all the home theater systems that they have in the store, and the average price there is $471.39. All right, now our sample was $452.80, and you found $471.39. So I'm going to give you a second. This question's going to pop up. Is there enough evidence to support your belief that the price has gone up? Why or why not? All right, so it's okay if you didn't get this. If you said yes, that's fine. But the answer is no. Okay, and the reason is this 471.39, that's in our confidence interval. Okay, so we're 90% sure that the average is somewhere between 427 and 477. So if you got 471, that's in that range. So that's not surprising. And that doesn't necessarily mean that the price has gone up. All right, last thing we're going to look at is finding a minimum sample size. So, you know, we want to know what the average of something is. We want to be able to make a confidence interval. We want to know how accurate it is. What's the lowest number of data points? What's the smallest sample size that I could go find? And this is the formula that we're going to use. Now, Z sub C stands for Z-score, and it's these numbers that go with these confidence levels. So if the problem says 95% confidence level, then you're going to use 1.96 for that Z sub C number. Okay, sigma is standard deviation. We've done that before. And then this E is the margin of error, okay, that the problem will give you. So let's look at an example. So a paint manufacturer uses a machine to fill gallon cans with paint. They want to know the mean volume of paint within 0.25 ounces. Okay, so they want your estimate to be within 0.25 ounces of the real thing. What's the minimum sample size required to construct a 90% confidence interval? And we're going to assume the population standard deviation is 0.85 ounces. All right, so we're going to use that formula from the previous slide. Okay, and so Z sub C, we're going to do a 90% confidence interval. So the Z number that goes with 90% is 1.645. So 1.645 is going to be multiplied by sigma, which is standard deviation. So that's going to be 0.85. That's going to go over the margin of error. And that's where we kind of look for the word within. All right, so the margin of error that they're giving us is 0.25 ounces. They want our numbers to be within 1/4 of an ounce. And then this whole thing is squared. So let's grab calculator. Move this over so you can see. All right, we're going to go menu, and we're going to go back to our regular calculator, which is number 1. All right, and then let's make sure we have enough parentheses here. So I'm going to do a parentheses for the whole thing and then parentheses for the top. So 1.645 times 0.85, that's the top of my fraction, divided by 0.25. All right, close my parentheses because that's the whole thing, and then we're going to square that, and that is equal to 31.28. All right, now we cannot sample 0.28 gallons of paint. All right, so we're always going to round minimum sample sizes up. Okay, so just like we did with our class width a long time ago in Unit 3, we're going to round this up and say our minimum sample size is 32. Okay, so if we want to make a confidence interval where we are 90% sure that we're within 0.25 ounces of the mean, we need to sample at least 32 cans of paint. All right, and that's it for 7A.